we're going to review laws of exponents. I need to stop assuming that you guys remember anything and just outright teach for the most part, even if it's Algebra 1. Can't do that though. We don't have enough time. I'm only one person. First up, there are 8 laws of exponents in total, about 8 laws of exponents. Each law tells you how to work with an exponential function, okay? This is very important for when we are solving and evaluating exponents and also solving and evaluating logs, because there are laws of logs that will apply as well. And as we've learned, exponents and logs are inverses of each other, right? And so we need to make sure we have a good understanding of both in order to work with the other. So up first, our first law is our product law. It's called the product law because you're multiplying. Product is a result of multiplication, correct? So when you're multiplying 2 exponents, what that means you're doing to their powers are adding them. Yes? Okay. Law 2. Law 2 is our power property. Our power property is stating that when you are multiplying exponents, you are literally just multiplying the exponents, okay? So m times n, this means that I'm multiplying m times n. I'm not adding them, not subtracting them. I'm just literally multiplying them. Okay. Our law 3 is our distribution property of exponents. When you distribute an exponent, it applies to all factors on the inside. So you're going to get an m and you're going to get an m. So you distribute to all factors on the inside. This is distribution over multiplication is the long title of it. But law 3, distribution of exponents over multiplication. Okay, or distribution product property or something like that. But law 3, okay. Law 4 is our zero power. Anything, I mean anything to the 0 is going to be 1. Anything to the 0 is going to be 1. Law 5 is our quotient property. Our quotient property is saying that when you are dividing exponents of the same base, you are subtracting their powers. Got it? Dividing exponents of the same base, we are subtracting their powers. Law 6 is distribution over a quotient. When you distribute over a quotient, the power goes to everything in the numerator and everything in the denominator. Law 7. Law 7 is our rational or our fractional power property. Okay, this is probably the new guy. Don't know why I made it 7 instead of 8. But this is probably our new guy. It's saying that when you have a fractional power, the numerator of the power is going to be the power of the factor. The denominator is going to be its root. A root meaning whether it's square root, fourth root, cube root, it's the root of that problem, okay? Sometimes you need to see it as an example. So for example, if I had a to the 2/3, this means that I have the cube root of a squared. Does that make sense? Or I have the cube root of a, and then I'm going to square it. Okay, it doesn't matter which way you do the math. It's all comes out to be the same. All right, last but not least is our law 8. It's our negative power law. If I have I can't talk, I'm so sorry. If I have a negative power, that means that it belongs in the denominator. It is not a negative number. It's just negatively displaced, okay? So these are our 8 laws that we will be utilizing in our notes. To start off, just want to clarify something on simplifying. When you're simplifying, you want to eliminate parentheses before you start. So distribute if you need to distribute. Number 2, the goal of simplifying is to condense the number of terms and or factors that you have, right? Make it as small as possible, combine what I can. You are not done until everything has been combined and all laws have been applied, okay? We're going to start off with the basics. So looking at numbers 1 and 2 in your notes, number 1, I have -4 times -4 to the 3rd power. Which law is being applied here? Or could be applied? Number 1. Law number 1, because this is multiplication. This is product. Because it's multiplication, even though I don't see it, it's Casper the Friendly 1 is the power that's here. So we have -4 to the 1 plus 3, which equals -4 to the 4th power. -4 to the 4th power means I'm multiplying -4 times -4 times -4 times -4. Okay, when you multiply, you have to multiply two numbers at a time. -4 times -4 is going to give us 16. -4 times -4 is going to give us 16. 16 times 16 is 256. Tomorrow. Oh, good job. All right, questions on number 1? No? All right, number 2. What law? So this was law. We applied law number 1. Number 2. What law should we apply here? Law 2. Law number 2, which means I'm going to do what? Multiply the power. So we have 2 times 3, which makes? So we have -3 to the 6. Okay, so -3 to the 6 means I'm asking myself what's -3 times -3 times -3 times -3 times -3 times -3. Again, only multiplying 2 at a time. So that gives me 9 times 9 times 9. Multiplying 2 at a time gives me 81 times 9. And then I multiply and I get 729. When we start walking up this hill, are we all okay on the ground? Yeah? No questions, comments, concerns? Okay. Throwing the variables at you. Probably. All right, number 3. What law am I applying here? I'm applying law 3. Right? That's because I have to distribute the power to everything on the inside. You get a power. You get a power. You get a power. We all got powers. So that leaves me with 3 to the 4th. Yes. X to the 4th. And y to the 2nd. Is there any more simplifying that needs to take place? No. All right. 4. Before I start, there's nothing to distribute, but I do need to combine these two factors. But how can I combine these two factors? No, it's not the butterfly effect because there's no equal sign in between them. It is just straight multiplication, okay? When you have a whole number, it can be turned into a fraction by putting it over 1. When you're multiplying fractions, you're multiplying the numerator times the numerator, the denominator times the denominator. This times 1, 1 times this. So that's going to give me m to the 7th over m to the 4th. Bless you. So what law am I applying now? It's gonna be, which is our quotient, right? And the quotient law tells me to do what? Subtract the exponent. So 7 minus 4, which gives me 3, m to the 3rd. Okay, are we good to keep walking? We're good though? All right. We're still good. We're walking. You said this is the 1v1, right? Yes, unit 3 is forever long. It's broken into 3 parts. It's broken into 3 parts. So we're on part A of 3.
Taking the third part.
Yes.
So this takes all the way into March.
This takes us all the way to April, end of April.
So what are you doing for so what is that?
It's trig. It's introduction to trigonometry. In May.
That'll do it.
Right.
That'll do it.
All right, here we go.
I'm ready to get the cat in town.
You have a whole year, so get over it. Here we go. Remember, we said we gotta get rid of parentheses. How do I get rid of parentheses? I distribute. We need to distribute. So I'm distributing this entire product to each one of these, right? So that's gonna give me x, y squared times 3x squared plus x, y squared times 2y squared.
Wait. Why didn't you have to watch it? You picked up the seat on the train.
Huh?
Why didn't you have to watch it?
I haven't done anything. I just distribute.
Oh.
Now, what property am I gonna apply? The first one, law number uno. All right, does 3 have a friend in the first term? So 3 is already done. Does x have a friend in the first term? So we have x squared and x to the 1. So how many x's do I have? 3. Does y have a friend? So I am done. On to the next. Start with your number. Does 2 have a friend? Nope. Does x have a friend? Does y have a friend? So how many y's do I have? Huh? Are my variables exactly the same? That is it. Your variables have to be exactly the same in order to add or subtract. And are my variables exactly the same? No. So we stop. All right, make sure we were listening. What is the answer to number 6? It's what? It's 1. Anything to the 0 power is 1. You do nothing else.
That was the hardest one on.
I know, it was terrible. What law is it? 4.
Is it really?
Isn't that not the 0 power? That's not what I wrote?
Oh, yes.
Got it? No matter what it is, if the power is 0, the answer is 1. And we keep it pushing. Got it? All right. I'm going to pause and let you process 7 and 8.
Process. We don't need processing.
You are. You're going to talk to each other. Use your mathematical vocabulary. All right. On 8, you will be using multiple laws. On 7, your hint is law number 1.
Law 1.
Law 1.
I just asked you.
Oh, I didn't understand your mouth.
That it's not.
I didn't understand what you mouthed me. I just said no.
I'm really over here looking like what else could it be?
I didn't know what your mouth said.
I was holding up a number 1.
Here, I apologize.
Okay.
I just get the picture. I think the point is adding the plus y plus c.
Writing? Let me know what the writing on this side.
I think it would be 4. But you just need the 4. So I just
They are. I'm not putting myself aside because I have a problem.
Yeah.
Okay.
Please come back. Please. The non-capital year, there's eight, well, this is 7 and 14 circles. I mean, you have the 60 minutes. to take both parts. You have 60 minutes to take both parts. It's the cap. No, you have 60 minutes to take both parts. So if you use up your 60 minutes.
No, I thought it was supposed to be where.
On your unit circle.
Combine these, right?
Yeah, I really don't know, I'm not understanding this.
It's not, I'm just like, I think that's just that, I don't know. You know, like, what I did, they just like.
So go back, what did we do on number 4, when we had a fraction and a whole? So look back at number 4, what do you need to do with those two things? You need to combine.
Wait, I don't have one.
What do you
That's
mean?
a fraction, that's a whole.
B3 on the bottom.
Wait.
No, the base stays the same, your base stays there. But so after we.
Wait, it's not
I'm
like.
gonna answer that question, then I'm gonna go to the problem. Like you start combining them, look at number 4. After we combine them,
You have to subtract out 3 and 6. You still have
we add them again. Well, we multiply them.
All right, let's see. Thank you guys for working together and talking it out. I hate to pause you. Let's just make sure we're good. What laws did I apply here? 1. So applying law number 1 gives me my base stays the same. I have y plus 2 plus 6, which equals y 4 to the y plus 8. And that's all you can do because you don't know the value of y, right? All right, on number 8, you apply multiple laws. So what was the first ones was law number. We had to do number 6 because we distribute over the quotient, right? You get a power, which is going to leave us with a to the and b to the 6. What did I do on this one? Distribute, which is law number 3, right? So we distribute 2, 2. And that gives me a to the 6 over b to the 3. This can be written as a fraction by adding it over 1. Yes. What do we do on number 4? And now you multiply straight across. Numerator times numerator, denominator times denominator. A to the 8th times a to the 6, b over 3, all over b to the 6. There we go. And what am I doing with my a's? So a to the 14, and 3 minus 6 is? Which tells me it belongs in the bottom. So this is a 14. Because 8 plus 6 is 14. So we went through pretty much 4 laws, right? So we had law 6 in the beginning, then law 3, then we had to apply law number 1, and then we used our quotient. What's quotient again?
Quotient is
5. Thank you. And last but not least, number 8, to make it in the denominator. I have no more laws I can use. All right. Yes. Okay. Next. You're up next. Go. 9 and 10. Talk it out. Work it out. Answer.
Yes.
What does that mean?
And it'd be the same thing for, yeah, B1.
You want to make it a variable?
It's
Or
it's
one.
no, it's just because the negative is never.
Yeah, it's just as you put what you want.
You're cheesing already. So beautiful. I think it's your calling to be a preacher. You call the number behind the bulletin? The seminar? Yeah, the one that's.
Yeah.
That's the spiritual pathway. I think it's your calling to be a former preacher, Rocket League preacher, Siege 6, all these. You're made to preach Siege 6. My bad. Siege, I come at Siege and Ring. You're destined to preach there, though. They're broke. But you don't pay. They're gonna be broke. So like they're living in poverty, but spreading the word of the gospel. Being rich. Basically. You get paid that much.
I mean, even if you want, you have to friendly one.
But they do say money is the root of all greed.
One on.
Maybe being broke is okay.
Oh, you're who one?
Imagine a priest wearing an apple. I said.
I was just making sure I don't.
Your face isn't changing. Wait, so it wouldn't have no house. It's 1/5 to the 1. It's one right to 1. And, but it's not.
All right, let's check and see what we got really quick for the bell rings. What do you get for number 9? 1/5. Good job. Because 5 to the -4 plus 3 equals 5 to the -1, which means we get 1/5. What do we get for number 10? 1/64. Good job. 2 to the -6 equals 1/2 to the 6, which equals 1/64. I have to look at it. Just by 8 to the 1.
Yeah.
All right. So we'll pick up here tomorrow. We're good.